Hi everyone. In this video, I'm going to show you how you can solve this entire paper of Mechanics 1 that came in the Cambridge examinations during their February-March 2025 sessions. I have also provided the timestamps in this video. You can use it to skip to any particular question that you find a bit difficult. But yes, for the students who want to see the entire solutions of this paper, let's get started. So for the first question, we are having three coplanar forces of the magnitudes 40 newtons, 30 newtons, and x newtons acting at a particular point in the directions as shown in the diagram. Now, given that all these three forces are in equilibrium, we have to find out the values of theta and this value of force, that is x newtons. So this is a very repetitive question that we get in N1. The only one thing you will need to do is, because the forces are in equilibrium, you can say that the upward force is equals to the bottom force and the left force is equal to the right force. So over here, there is only one force which is not directly in the x-axis or the vertical axis, and therefore we'll need to resolve this force. Now, because over here we are having the force of x newtons and over here it's theta. So in order to rotate or resolve this x force in the x direction, because theta comes in between, we can say that it's going to become x cos theta. Similarly, if I try to resolve this x in the vertical axis, because theta does not come into the picture, so I can say that it's x sine theta. Now, because I've resolved this x newtons in its respective horizontal and the vertical direction, I can get rid of this. And now I can say that my 40 is equals to x cos theta and 30 is equals to x sine theta. And then I can just solve for theta and then for x. Let me show you how I have done this. So from the diagram, I have copied the force in the x direction, 40 is equals to x cos theta, and for the y direction, it is 30 is equals to x sine theta. Now to find theta, I am going to divide my y equation with the x so that I can get sine theta over cos theta, which is equals to tan theta. And in doing this process, over here I am going to get tan theta is equals to 30 by 40, which is 3 by 4. And if you solve using CAIE, you will be getting 36.8698 something. Now, once we are having the value of theta, I can find out the value of x just by putting the theta either in the equation of x or y. You can choose it. So I have over here chosen the equation for the x, and therefore I'm going to get the value of x is equals to 40 over cos of this angle, and that is going to be coming out to be 50 newtons. So yes, that is how you solve the first question, where the final answers are 50 newtons for the x and the theta is equal to 36.9 degrees, correct to one decimal place. Now moving on to the second question, we are having a cyclist who is traveling along a straight horizontal road at a speed of 4 meter per second when she is going to pass at a point O. Then she is going to accelerate at a constant rate for the distance of 42 meters, which means that the acceleration becomes constant over here, and it's going to achieve the speed of v meter per second after traveling this much distance. Then she's going to maintain the speed of v meter per second for another 50 meters. After that, she is going to deaccelerate at this rate before coming to the rest. Now, the distance traveled during the deacceleration is going to be 16 meters. In the first part, we are asked to find out the value of velocity v. So the best way to solve this kind of questions, I either try to draw the whole scenario of what's really happening if there are multiple points, but over here because there is only one point, that is O, and then the cyclist is just traveling in the forward direction. So I'm just going to draw a VT graph, and from the VT graph, I can solve this entire question. So let me show you how I have solved this. So based on the information given to us in the question, I have drawn this VT graph. She is starting from 4 meter per second and then travels at a constant rate until she reaches the value of velocity of v meter per second. And in this motion, she is going to cover the distance of 42 meters. Then she is going to maintain the speed of v meter per second for another 50 meters. And then she is going to deaccelerate at this value, that is minus 2 meter per second square, for another 16 meters just before she comes to rest. Now, based on this information, if we have to find out the value of v, I can see that for the first motion, the time is unknown. For the second motion, the time is unknown. So I can just use the third motion because over here it's straightforward. I know that the final velocity is going to be 0, initial velocity is going to be v, the acceleration is minus 2, and that's it. I just need to find out the value of velocity. The displacement is also given to us as 16. So based on this information, if I can show you the calculations, I got the value of v by using v square is equal to u square plus 2as as 8 meter per second. Now moving on to the second part, we are asked to find out the total time for which she is in the motion from the instant that she passes through. So basically, we are just asked to calculate the total time taken for this entire journey by the cyclist. Cyclist or, yeah, cyclist, yes. So let's see how we can do this. So the idea over here is I am first of all going to calculate the time interval for all the three motions. Then I'm going to add all these times together to find the total time taken by the cyclist to complete the journey. So to find the first time interval, that is to find the value of t1, I'm going to use the area of the VT curve, which is displacement. And therefore, I'm going to say that because it's a trapezium over here, the area of trapezium is given by the sum of the parallel sides into height of the trapezium divided by 2. So I can say that 42, which is the area, is equal to 4 plus 8 divided by 2 times the height, that is t1. And from here, I'm going to get t1 is equal to 7 seconds. Then moving on to find the second time interval, that is in between t1 and t2. I know that again, I can use the concept of area under the curve. So because it's a rectangle, I can say that 8, that is the height of the rectangle, times the time interval should be equal to 50. So 8t is equals to 50 is going to help me get the second time interval, and that comes out to be 6.25 seconds. So if this is 6.25 seconds and the first one is 7 seconds, at t2 we are having a total time of 13.25 seconds. And just similar to this, I'm going to find out the time interval for the last part. And the way that I'm going to do is I know over here that the acceleration is -2. So using the value of the acceleration and the gradient of this line, I can find out this time interval. So yeah, -8 by t is equals to -2. From here, I get t is equal to 4 seconds. And because I know that till t2 it was 13.25 seconds, if I add another 4 seconds, the total time taken for this journey is going to become 17.25 seconds. Now for the third question, an airplane is given to us which is flying at a constant speed, which means that the value of acceleration is equal to 0. In the first part, the aeroplane is flying horizontally, and the engines of the airplanes are producing the constant power of this much watts. And then the aeroplane is also experiencing a constant horizontal resistance of 25 kilonewtons. We are asked to find out the speed of the airplane. Now, because I know that we are having an airplane which is experiencing a backward force of 25 kilonewtons, and because it's traveling at a constant speed, we don't have any kind of acceleration. It means that the left force is equal to the right hand force. It is traveling in equilibrium. So my driving force will be equal to 25 kilograms. Now that I know that what is the value of the driving force, I know what is the power used to produce this much of driving force. I can find out the velocity just by applying power is equal to the driving force into the velocity formula. And therefore the answer over here is going to be, let me show you, 220 meter per second. That's how we solve the first part. Now for the B part, we are given the aeroplane that is going to ascend 300 meters in 50 seconds. So let's say in 50 seconds, now the aeroplane is going to climb the height, and vertically it's going to be 300 meters, which it's traveling just in 50 seconds. And it's also going to maintain the same speed. It basically means there is no change in kinetic energy. It's going to be zero. The resistive force is no longer constant, and the work done against this resistive force in this motion is going to be this many joules. So even the work done because of the resistive force is given to us in this entire motion, and the mass of the airplane is also given to us. We are asked to find out the average power of the airplane's engine. Now, just by looking into the question itself, we can say that over here we need to use work energy equation, which is given by delta work done is equals to the delta K plus delta P. So what is the change in the work? What is the change in the K and what is the change in P? If we are able to calculate all three, we can solve this question. So yeah, let me show you how I have done this. To start with, this is the work energy equation in which the change in the work done can be found using work done because of the driving force minus the work done because of the resistive force. So this value is already provided to us in the question, which I have mentioned over here as well. But then what about the work done because of the driving force? I know that the power of the airplane is going to produce some kind of force, and because of that, there can be a work done. So, what's the relationship between the power work done? So, I know that power is equals to work done divided by time, and therefore I can say that the work done because of the driving force is going to become power into time. So, time taken for this motion is 50 seconds, and therefore I've written that the work done because of the driving force is 50 joules. Now, this is the power that we are trying to find. Now that I know these two values, what about delta K? Delta K as we know is 0. What about delta P? It is mg times delta height. That is final height minus initial height. I know that the final height is going to be 300 meters. Initial, because we are taking this as a reference, that is going to be 0. And by getting the mass times g times the change in height, That is what my delta P is going to look like. So after substituting all the values back into this equation, I'm going to get the value of the power as 9000 kilovolts. And now moving towards the fourth question, it's a repetitive question where we know that this kind of situations are given in a lot of different past paper questions. So over here, because the object A is heavier than the object B, object A is going to travel down and object B is going to travel upwards. Initially, both of them are at rest and the distance from the ground before the motion is x meters. And then in this case, we have to find the tension in the string and the acceleration of the particles the moment the system is released from the rest. So over here, you should be aware about how to draw the force body diagrams for both the objects, from which you will be making equations for A and B, and then just solve these equations together in order to find the tension as well as the acceleration. Let me show you how I have done it over here. So now for the particle A, mass is 0.3 kg. For particle B, mass is 0.1 kg. And for both of them, the weight is going to obviously act vertically downwards. For particle A, it's 0.3 g. For particle B, it is 0.1 g. And then because both of them are connected with the same inextensible string, it means that their tension is going to be same. And also because it is inextensible, the acceleration is also going to be the same. And from here, I can say that because A is going to move downwards, in which the acceleration is going to be positive for A. So I can say that the downward force minus the upward force will be the F net value. And then using the F net is equals to ma, I can get the equation for the particle A being weight minus the tension is equals to ma. Similarly, for the particle B, because it's traveling upwards and also the acceleration in that direction is positive, I can say that the upward force is positive and the downward force is negative. And therefore, tension minus the weight will be the net force. And therefore, the F net is equals to ma equation for the particle B is going to look like this. And over here, I can simply solve this equation by adding these equations to eliminate the t and find the value of A as 5 meter per second square. And then I can substitute the value of A either in the first equation or the second equation to find out the value of the tension. Over here, I have substituted the value of the acceleration in the particle B, and I'm going to get the value of T as 1.5 newtons. And therefore, I can say that for this question, the tension is going to be 1.5 newtons and the acceleration is going to become 5 meter per second square. And now for the second part, it's given that during the subsequent motion, B does not reach the pulley, and when A reaches the ground, it comes to the rest. Given that the greatest height of B above the ground is 1.2 meters, we have to find out the value of x. So the idea over here is, again, the question is very repetitive. When A is going to hit the ground, the moment it hits the ground, it's going to be at rest. And because it's traveling with the same string, so as A travels downwards, B is also going to travel upwards. So as A is going to travel x meters, B is going to travel x meters from this point. So this is another x meters. And then the moment just before it hits the ground, when A just hits the ground, at that time it's going to have certain kind of velocity. And that same velocity can be said that particle B is also going to have because they are connected with the same string. So if A is having certain speed over here, B at the same instant is going to have the same speed. So let's say it's going to be UB. So this UB and VA will be equal to each other. Why am I calling it UB over here? Because A comes to the rest, but then what happens to B? Does B also come to rest? No. It has open space upwards. So now until the value of this velocity does not become zero, it can travel further upwards. Let's say at this particular instant, the value of the velocity of the particle B becomes zero. That is the greatest height achieved by the object B. So this x plus the additional distance over here, that summation of all of this is going to be coming out to be, I guess it was mentioned as 1.2 meters. Yeah, 1.2 meters. So from here, I can say that my s plus 2x is coming out to be 1.2. And from here, I can say that my s, that is the additional distance that it's going to travel until this velocity becomes 0, is going to be equal to 1.2 minus 2x. The reason I'm writing it over here because I'll be using this in the calculations. But I hope that this part is clear to you that this is the greatest height achieved by the particle B. And using this information, we just need to find out the value of x. The first process is to find out what is the velocity of the particle A just before it hits the ground. That will be the same velocity for the particle B when it's going to travel in the upward direction due to the acceleration of the gravity. And over here, we are going to just calculate this distance with respect to x until this velocity becomes 0. And that is how I'm going to find this x. Let me show you exactly what I have done over here to get the value of x. So to start with, I am finding the value of the velocity of the particle A as it reaches the ground. In this process, I know that the initial value of the velocity is going to be 0. The acceleration, because it's traveling under the influence of that whole tension between the particle and particle B, the value of this acceleration we found in the previous part is 5 meter per second squared. And the distance it's going to travel in this motion just before it hits the ground is going to be x meters. And therefore, utilizing the formula of v square is equal to u square plus 2as, I can say that va square is equals to 10x. Now, because of the experience, I have solved a lot of questions like this from the past papers. There is no point in just finding the value of va. If you want, you can say that v is equals to under root of 10x. But then in the next step, you're again going to square that. And that is why, because of the experience, just because of that, I am not just taking the under root of 10x to find the va and keeping va square as it is. So now, because I know that once the A is going to hit the ground, B is also going to be traveling x meters upwards, and the value of the velocity at that particular instant for the particle B is going to be exactly the same. And then after that particular part, B is going to travel just under the influence of gravity until the value of the velocity of the particle B becomes 0. And now in the next motion, if I can show it to you over here, when A reaches the ground, my value of the velocity for the particle B is going to be as it is, that is 10x if I square the velocity. And then the distance it's going to travel, this extra distance it's going to travel, as I explained you earlier, is going to become 1.2 minus 2x, right? From the whole 1.2, if I just remove this 2x, this is the additional distance my particle B is going to travel before it reaches the value of velocity of 0. Again, implementing v square is equal to u square plus 2as, the final velocity now is going to be 0. The initial velocity square is going to be 10x. That is the reason why I was not taking the under root of 10x. It's just useless. Then, because it's traveling under the influence of gravity, we know that we take the value of the gravity as 10. So yeah, because it's traveling opposing the gravity, it's going to be minus 10, right? So 2 times minus 10 is minus 20 times the s is 1.2 minus 2x. And now from this equation, I can simply figure out that the value of x is going to be coming out to be 0.48 meters. So yes guys, that is how we solve this particular part. Now moving on to the fifth question, we are having three particles P, Q and R of the respective masses as shown in the diagram, which are initially at rest in a straight line on a smooth horizontal plane. The distance from P to Q is 3 meters and so on and so forth for Q to R is also 3 meters. Now P is projected directly towards the particle Q with the initial speed of 3 meter per second. And then because the plane is smooth, it means that it's not going to decrease the value of velocity. My velocity is going to be constant. And therefore, after the collision between P and Q, P continues to move in the same direction with the speed of 1.5 meter per second. And in the first part, we are asked to find out the speed of the Q after the collision. So we are just talking about this part, and the first part is simply based on the collision. So I just need to find out what is my initial and after condition. So before the collision, that is how it's going to be. My Q is at rest. P is traveling towards the Q with this particular speed. And my after condition is going to be like this. P and Q are both moving towards the right direction. But now the value of the velocity of the particle P is 1.5 meter per second. Now applying the conservation of the momentum, that is the initial momentum equals to final momentum, I can figure out the value of the velocity of the particle Q. So before the collision, it's going to become 0.6 into 3 plus 0.4 into 0, which is simply 0. So that is how I get the left part. And for the after part, it's going to be 0.6 into 1.5 plus 0.4, that is the mass of particle Q, into its speed, which we are trying to find. And if you solve this, you get the value of the particle Q just after the collision. Its velocity is going to be 2.25 meter per second. That is how we solve the first part. And then for the next part, it says that in the subsequent collision between the particle Q and R, the particles are going to collize. It means that Q and R are going to have just bombarded into each other and just form one single particle. We have to find the speed of the combined particle after the collision. So again, I'm going to show you the before after situation. So now we found out that after Q has gone through the collision with particle P, it's going to travel to the right side with the speed of 2.25 meter per second. Then R was at rest. And then in the after situation, Q plus R gets combined together and moves in the right direction. the combined mass is going to become 0.4 plus 0.8, which is 1.2 kg. Again, implementing the conservation of momentum, the answer that I'm going to get over here is going to be 0.4 kg for the particle q, that is 2.25 is the velocity, is equals to q plus r is 1.2 kgs times its respective velocity. And then making vqr the subject of formula, it's going to be 0.75 meter per second. So after the collision, q and r together combined are going to move towards the right hand side with this particular speed. That is what we understand from the part B. Now for the final part of this question, we have to find the time it takes from the instant when P is initially projected until the instant at which P collides with the combined particle. Now over here, I am going to say that there are three different motions that are happening. The first motion is when P is going to collide with Q, and then when Q collides with R, and then P catches up and collides with the combined particle Q and R. If I am able to find out the time taken in all these three journeys, then I can simply combine all of this time together, as in add all this together to get the complete time for the entire motion. Let me show you how I have done this. The first time interval that I'm interested in is when P is going to move towards the particle Q by traveling this 3 meters. I know that throughout this whole motion, because the plane is smooth, the value of the velocity is unchanged. It means that the acceleration is zero. So because I know that P is traveling towards the Q with the velocity of 3 meter per second and the distance it's going to cover is 3 meters, I can find out that initial time period. And that is what I have done over here. If I can show it to you, S is equal to ut is what I have used because acceleration is equal to zero. And in doing this, I got that the time is equals to 1 second. Now, once P and Q are both at this particular position, Q is now going to start move towards the right hand direction and also P moves in the same direction. So the second thing that I'm interested in is what is the time taken for the particle Q to travel this 3 meters before it hits the particle R. Now for this I'll need to know what is the value of the velocity at which Q is moving towards the right hand side. And that value that we have figured out is 2.25 meter per second. And again, because it's traveling 3 meter per second, I can use S is equal to ut because again the value of the acceleration is 0 over here. So if I can show it to you, it's over here. S is equal to ut and I got the value of Ts 4 by 3 meter per second, or I should say 4 by 3 seconds. Now, in this particular seconds, P is also traveling towards the right hand direction. So I want to figure out that in this 4 by 3 seconds, what is the distance covered by the particle P. So after the collision with the particle Q, P is now traveling at 1.5 meter per second in the right hand direction. And now I know the value of time is 4 by 3 seconds. So in this much seconds, what is the distance traveled? And that is what I have calculated in the next part. So S is equal to ut is what I'm using again. The value of the speed is now 1.5 after the collision and it's multiplied with 4 by 3, which is the time. So I can say that the distance traveled by the particle P is 2 meters. So once P has collided with the Q, it's going to travel another 2 meters when Q is going to meet the particle R. So between the particle QR and the particle P, there is only 1 meter of difference left. If I can show that diagram to you that I've drawn over here, that is how it's going to look like. And now as the QR is going to move towards right, it's going to have some extra distance. That is the distance traveled by the QR. So P needs to cover the entire distance, that is 1 meter plus the additional distance traveled by the QR, so that I can say that now P is going to meet the particles Q and R. So the total distance P needs to travel is 1 plus the additional distance traveled by QR, and then I simply can find out the value of the time again by using S is equal to ut over here. So if I can show my calculations, that is how it's going to look like. First of all, I am figuring out what is the distance traveled by the particle QR using S is equal to ut. So after the collision of QR, I know that it's going to travel together towards the right hand direction with the speed 0.75. So 0.75 times the t is the additional distance traveled by the particle QR. And then I'm saying that for the particle P, it's going to be 1 meter between P plus QR. And then the additional distance that QR is going to travel is 0.75 t is equals to ut. Because P is having the speed of 1.5, that is why I used 1.5 t over here. If you solve this equation, you will get the value of the time interval for this P to catch up the particle QR is going to be again 4 by 3 seconds. So in the first interval, it was 1 second. In the second interval, it is 4 by 3. And even in the final interval, it is 4 by 3 seconds. If you add all of these values together, you will be having the complete time taken in this journey coming out to be 11 by 3 seconds. That is how we saw this part. Now for the next question, we are having this diagram in which we can see that there is a block of mass 12 kg, which is placed on a rough inclined plane, which is inclined at this angle of alpha from the horizontal. The value of alpha is given as 10 inverse of 0.5. Then there is a force of x which is trying to pull the block upwards. The force is parallel to the plane. The coefficient of friction between the block and the plane is given by mu. In the first part, it is given that the value of mu and x is 0.15 and 20 respectively. We have to find the time that it's going to take for the block to move 2 meters down the plane from the rest. So initially the block is at rest, and then because there is also the force of gravity which is going to pull it downwards, the value of x is not enough to pull the block upwards, and that is why the block is going to move in the downward direction. And what is the time it's going to take for the block to move 2 meters down the plane? That is what is asked in the first part. And for this, we'll be requiring the force body diagram, and that is what I have drawn over here. So I know that the weight is going to act in this direction, and if this is alpha, this is going to be alpha as well. So if I rotate my, or if I say if I resolve my weight vector in the direction that is perpendicular to the plane, because the value of alpha comes in between, this becomes weight cos alpha, and therefore this becomes weight sine alpha. That is how I have written these two forces because of the weight. And then because of this force, 120 sine alpha or 12g sine alpha, this force is dominated as compared to the x over here. There is also, don't forget, a friction force because the block is going to move in the downwards plane. The friction force is going to act opposite to that. That is why I have marked it with the x. So this combined force is not enough, and therefore the block is going to slide down. And yeah, let me show you how I can use this kind of force body diagram in order to find the total time it's going to take for the block to move 2 meters in the downward direction. The first step that I've done over here is I've utilized the information that my alpha is equals to 10 inverse of 0.5 to get the exact value of sine alpha and the cos alpha. I'm doing this so that I don't make any kind of mistakes because of the round off errors. And my calculations are neat and clean, okay, without any kind of decimals involved. So yeah, the first thing that I've done is from this equation I've said that my 10 alpha is equals to half. Then I'm drawing this right angle triangle. I know that 10 is opposite over adjacent. So in the opposite side I'm writing 1. In the adjacent side I've marked 2. And then to calculate the hypotenuse I'm using Pythagoras theorem. That is how I get root 5 over here. Then to get my sine alpha I'm using opposite over hypotenuse, that is 1 by root 5. And for the cos alpha I'm using adjacent over hypotenuse, which is 2 by root 5. Once I'm having this value, I'm going to go ahead and find out the value of r. My r, because in this perpendicular to the plane, there is no acceleration, I can say that my r is equals to 120 g cos alpha, or that is because I know that g is equal to 10, I can say that my r is equals to 120 cos alpha. And because cos alpha is 2 by root 5, I can say that the value of r that I'm going to get over here is 48 root 5. Now, once I'm having the value of r, I can also find out the value of the friction force, which is simply given by mu r. The mu that I'm supposed to use is 0.15. The value of r that I've just figured out is 48 root 5. And therefore, I can say that the friction force over here is going to be 36 root 5 over 5 newtons. And now that I know what is the value of this friction force, the value of x is 20 newtons. And I also know what is the value of the force in the downward direction. I can use my F net is equals to ma to find out the acceleration the instant the block is going to move in the downward direction. So yeah, once I'm having the value of the acceleration, I can use the Stewart equations to find out the time it takes for this block to move 2 units in the downward direction. And therefore, over here to find out the value of the acceleration, I'm going to have my F net written over here. Because my block is traveling in the downward direction where the acceleration is positive, I can say that 120 sine alpha is the positive force and x plus f is the negative force. And therefore the F net is going to become 120 sine alpha minus x minus f. And that is what I've written over here, which is equals to ma. The value of the mass of the block is 12 kilograms, and that is what is 12a. Solving this equation in the CAIE directly, I got the value of the acceleration as 1.4638 something something meter per second square. Now that I'm having the value of the acceleration, let me use Stewart equations to find out the value of time. Initially note that the block was at rest. So the value of u over here becomes 0. And then implementing s is equal to ut plus half at square. The distance it's going to travel is 2. The value of the acceleration is 1.4638. And then the value of time by using this formula, I'll be getting 1.65 seconds correct to three significant figures. That is how you solve the first part of this question. Moving on to part B, it's given that the value of mu is now not equal to 0.15 and that when the value of x is kept at 10 newtons, the block is on the point of moving down the plane. It means that we are talking about limiting equilibrium. Whenever an object is about to either move up or down, it is still in the equilibrium position. But now, because from the information that it's about to move downwards, we know that in this case, friction is going to act in the up the plane direction. Similarly, for the second information, we are asked to find out the value of mu and the value of x. Now, value of x is not equal to 10. We have to find the new value of x for which the block is on the point of moving up the plane. So this is the second scenario where you are giving enough force to the block so that it's just on the point that it starts moving in the upward direction. Still, it hasn't moved. But let's say if I give any extra force on top of what I already find in x, then it's going to move in the upward direction. So this is the limiting equilibrium for the upward case. It means that for the second scenario, the friction is going to act down the plane. Now, utilizing both the information, I'm going to have a rough free body diagram and then create two different equations with two unknowns being mu and x. Solve these equations together, and that's how I'll be done with this part. So to start with the solution, as you can see that I'm starting with the first condition where the block is about to move downwards, and therefore you can see that the friction force is going to be in the upward direction. And now because we are in the limiting equilibrium condition, it means that there is no acceleration. It means that all the kind of force down the plane will be equal to the force up the plane. That is why 10 plus f will be equal to 120 sine alpha. And the value of the sine alpha was 1 by root 5. If I can show it to you over here, that is what we had figured out. The final value of the f is going to be come out to this. And then because I know that the friction force is mu into r, I have simply said that the value of r is coming out to be 120 cos of alpha, which is 120 into 2 by root 5. And from here, I'm going to make mu the subject of formula. So mu into r is equals to the friction force. Mu will be equal to friction force over the normal force or the reaction force. So yeah, this is the friction force we got over here, and the reaction force is written in the bottom part. You can use your calculator to find out the value of mu in decimals if you like. But yeah, that is how I'm going to get the value of my mu. Once I'm having the value of mu, I can just use the second condition, that is limiting equilibrium, but this time up the plane. And therefore the same diagram I can repeat with the force F being in the downward direction. And then if I can just show that to you over here, that is how it's going to look like. And then again, because it's in equilibrium, I can say that this x is equals to f plus 120 sine alpha. Now over here, I can say that because the value of f I've already figured out over here as this value. So that f plus 120 sine alpha, the sine alpha is 1 by root 5. If I calculate, the value of x in decimals will come out to be 97.3312 something. And therefore, the final value of mu and x from here, I can say that it's going to be 0.407 for mu, correct to three significant figures, and 97.3 for x, correct to three significant figures. And that's the kind of conclusion that you can see as my final statement in this part. Now, for the last question, it's coming from the variable acceleration, where the equation for the velocity in terms of time is given over here, where k and p both are constants. And then the acceleration of the particle at t is equal to 1 is given as 42 meter per second square. And the displacement of the particle at t is equal to 1 is given as 93 meters. In the first part, we have to show that the value of k is equal to 3 and the value of p comes out to be 26. I know that because it's a variable acceleration. From the equation of velocity, if I have to find acceleration, I can simply take the derivative over here. And then to find displacement from the equation of velocity, I can integrate. So yeah, using this kind of ideology, let me show you how I have done the first part. First of all, what I'm doing is I'm utilizing the information about the acceleration. I know that A is equals to dv dt. So I'm going to find my dv dt over here like this. And then I'm substituting the value of t as 1, A as 42, and finally getting my k is equals to 42 over p minus 12. Similarly, I'm going to do the same thing for the displacement. I know that the displacement is the integration of v, as you can see. So I'm taking this equation, I'm integrating it, and then once I'm done with the integration part, I'm having the integration constant. I know that when I'm about to start my motion, the displacement is 0 at t is equal to 0, and therefore c is also equal to 0. Then substituting the value of t as 1 and s as 93, I'll be getting another equation for k in terms of p, if I can show that to you over here. It's going to be k is equals to 186 over 36 plus p. Now because I'm having both the k's, I'm going to equate both of them with each other and find the value of p. And in this process, I'm going to get the value of p as 26. And then if I put my 26 back into either of this equation, I'm going to get the value of k over here. If I can show it to you, I've used this equation to get the value of k as 3. And therefore, I have proved that the value of p is 26 and the value of k is 3. And now for the next part, we are asked to find the distance moved by the particle between the time at which the acceleration is 0 and the time at which the velocity is 0. So because I'm having the acceleration and the velocity equations both, I'm going to first of all find out the values of the time when both of them are equal to 0. And after that, I'm going to just use this integration output and put the values of the time from the lowest to the highest and find out the value of the displacement within the given time interval. So let me show you how I have done this. So first of all, over here you can see that I've used when a is equal to 0. I know that the equation that I'm going to use is this one. So 0 is equals to k times p minus 12t. The value of k is 3, the value of p is 26. And that is how I get the first equation, from which I can say that t is equals to 13 by 6 seconds. And then utilizing the information that when v is equal to 0, so over here, this is the equation of the v over here, right? And I'm putting the value of v as 0 to find out the value of time. And if I can show you the output that I'm getting over here, it's going to be a quadratic equation. I'm using my calculator to solve it. And the correct value that I'm going to get over here for the time is going to be 5 seconds. So in between 13 by 6 seconds to 5 seconds, I am going to utilize the output of the integral over here and simply put the limits from 13 by 6 to 5 and find the final value of the displacement as we want in the part B. And therefore the final steps for this question is going to be over here. Utilizing the information from the integral, putting the 5 to get 525, putting 13 by 6 to get 4537 over 18, and then the final value of the displacement between the given time interval is 4913 over 18. That is how you solve this entire paper. Thank you so much guys for watching the video so far. In case of any kind of doubts for whatever questions, let me know in the comments. And you can also reach out to me on this WhatsApp number. If you are having any kind of queries, let's say if you want to boost up your grade, you want 1v1 live classes with me, that is a private online classes with me. For all the kind of discussions, you can reach out to me via this number and we can have our discussions. Thank you so much guys once again for watching this entire video. I'll see you in the next one.